Hello everybody, hope you guys are doing well. So, continuing on our journey with Swift, today we will be starting with UI. We have already covered the Swift programming language, so now we will start with the UI, developing the user interface using Swift. Okay, now working with views. Let's see. So we will be Storm Viewer. So this is our first thing. We will be that users scroll. We will be generating an app that lets users scroll through a list of images and then select one to view. It's really simple because there might be other things that we need to learn along the way. So let's get started. Let's open Xcode. Now let's create a new project. Let's name this as Storm Viewer VIEW. Let's click on next, create, and this is the basic view. Let's delete this. So, oh yeah, let's delete this. There you go. For product, enter the name Storm Viewer, which is done. One of the fields you'll find is organization and identifier. This is a unique identifier usually made up of your personal website domain name in reverse. So it's the storm.hacking with Swift. If I were making an app, you'll need to put something valid in there if you're deploying devices, but otherwise you can just keep it com.example. Okay, perfect. Now let's in SwiftUI we can. Okay, so now let's see how the UI. Now see how so you can develop UI in CSS as well, right? In like using CSS when we create web pages, we inherently what we are doing there is also making up the UI. The difference between CSS and SwiftUI is CSS is not very descriptive. I mean, CSS is something which can do some kind of processing as compared to SwiftUI. On the other hand, SwiftUI is very descriptive. That means if you want to place an element horizontally, you will have to like it's very what do you say it's more descriptive than, so whatever you write it will be exactly that same. So that's why in CSS when there is different like the architect, I mean the way you write CSS and cascading, like I mean okay it's cascading, but then it's very like CSS has built in, so it's very what do you say um it is this is very declarative, like the way you write, the way is the UI. So then that's why you find, so whatever you declare exactly same, but then CSS kind of has its own logical thinking, and then hence the way we write SwiftUI or the way we do UI development in Android or like in mobile develop, it has to be more specific. That's why we have a declarative type of code, and CSS is not that declarative. It's more, it kind of assumes a lot of things. I mean, for example, when you lay out elements, CSS kind of does some, it's not that descriptive, CSS is not very descriptive. Let's see does that what does that bring up. Yeah, so it's less descriptive, but then certain things are assumed by CSS, and that's why the way layout works, you don't have a horizontal or something else in CSS as compared to SwiftUI, as compared to UI development in mobile apps. No, okay. Now content view. Now remember, this content view is a structure that is conforming to the view protocol. Now inside that I have a property. Now this is where property sum view. Now sum is a keyword. We'll see what that means when we go ahead. Oh yes, it's not started. Okay, and there are lots of small content view. All our Swift layouts are structs because behind the scenes these are very simpler, easy to generate. The struct conforms to the view protocol. The struct has a computed property called body, which is the only requirement of the view protocol. This is where you create your layouts. As you see, this is the return value. This has a return value some view, which means this view will itself return some sorts of views. It might be text, images, sliders, buttons, and so on. In this case, our body contains only one thing, which is a text view with string hello world. After that, so is saying this is a struct. Now this struct is the instance is created by the Xcode itself. You don't know to do. We don't have to. Then we have so, and this is conforming to a protocol called view. Then we have a property where body. Now this is a closure. Now what is this is saying is it's going to return you some view. Which is only requirement. Now this is a computed property, remember, p body. Now why this is, so sum is an associated value. Let's see what sum does. So in okay, just give me a minute. Okay. The struct conforms to you. Now what is we were searching about sum, right? Sorry for that. Now sum. Now the sum keyword is used to represent an opaque return type. This is primarily used when you want to specify a return type without exposing its underlying type, essentially hiding the implementation details while still conforming to a protocol or certain state. Opaque prototypes. Now with some, Swift knows that the type is, but doesn't reveal it explicitly. It helps with hiding complexity, like when you want to return a specific type but don't want to expose its implementation details. This is useful when you want to promise that a return type conforms to. Okay, now let's see what are opaque types. This is not this is I haven't what's the advantage of using opaque types. The key concepts: you specify a function returns some types that conform to a particular protocol. Swift ensure that the return type will always be the same concrete type each time. Protocol conformance when you use some no, the return type of the create button is some view. Exact type of the return value is not exposed to the caller. The caller does not. What's the? Okay, so now there is a catch, I will say. Now, if I'm conforming to a protocol, the computed properties should also conform. Okay, I guess that's what was. If we why is this vibrating? Let's see if let's see. The compression is on. Noise suppression is on. Shaking. First of all, why is it shaking so much? It shouldn't shake. Oh. Yeah, so you are with. Oh, okay. If you. Okay, so when we conform to a protocol, the return type of a computed property or a method should really conform to the same protocol. This means it meant to represent the value of the type. Let's see. So now I have this is a protocol, right? And now I'm to the shape. So circle is conforming to shape, the computed property conforming to the shape. So then my computed property needs to conform. No. So he says the struct has a computed property called body, which is the only requirement of the view protocol. He says okay, so is the body present in view protocol? Like how is the okay, let's see. Oh, let's see view pro what we have in view protocol. Let's see. So this is basically an associated type. Then I have a body view. This is a property. This returns the view protocol has an associated type called body. This type represents the content in the view, and then the body is a property that returns another view. So this is okay, so he's talking about this. Now this should return another view or a composition of multiples. Now the variable body the which is another view that conforms to the view protocol. So now what I'm going to do is, so my content view structure is going to conform to this, and then what is an associated type? Associated. Okay, so an associated type is it allows you to define the placeholder types in the protocol, which are determined by the types that conform. Now, what is in an associated? An associated type defines a type placeholder inside a protocol. It enables the protocol to be generic in a way that the exact type can be determined by each conforming type. The associated type is only specified when concrete type adopts. So when I say associated type, this defines a placeholder type that will be provided when the type conforms to some protocol. So what I am saying is this okay, so right now this there is no, see, I have, this is the protocol container. I have, this is get set. Now I'm mutating function because I'm trying to have a function in a structure and to maintain the the copies. Yeah. And then what's this item? Okay, so as I said, the protocol container as an associated type item. This means that any type conforming to the container must define what item will be in container. Okay, so this is basically an array of items, right? So I'm saying this is an int. So then items is int. So what's the, oh, see, what if I declared its type? Why? Remember, I have not done any okay, so associated type removes the annotation. Does it? Yeah. Okay, so the associated time protocol defines a placeholder time that will be defined that are generic and can vary. Okay, so we are explicitly stating that the container holds, this is int, right? That's what it's saying here, I guess. But then this will not conform to the, because if we have a string, oh, we have something else, so then that wouldn't work. Okay, where we are. So we said this is the, oh, the view protocol. Forgot about the view protocol. Let's okay. Okay, so this is the view protocol, right? Now we are saying that the content in view is conforming to this view. Perfect. Now associated type body view, the view protocol has an associated type called body. Now associated type means this is going to return the view protocol has an associated type called body. This is the associated type. This means this type representing the current. Then why have we, if this is associated, okay, why do we have a notation here? If it says the confirming class is supposed to provide the implementation. Okay, now the reason for annotation in the context of view protocol is due to the way sessions work within a protocol. Even though the confirming class struct is provided the actual implementation, the protocol itself needs to define the requirements of the type in a way that the compiler can use for type checking informations. When the type conforms to the view protocol, it must provide a body property that returns a view. Here's a basic structure. Defining that the protocol view is generic over the type of body. When you conform to view, you are essentially declaring that you will provide a body property and the body will return a specific type that conform. Oh, so basically we are mentioning that whatever returns should also conform to the view protocol. Is this what? So just does that does this mean that the mm, mm, the value which will be or which will also conform the view protocol, something like that. I guess that's what is. Yeah, that's exactly. Now, okay, the property requires that any type conform. Okay, so now this is basically we are mentioning the associated type, right? We are saying that this body is going to, and then we are giving it self dot body is assigned over here. Oh, so what is happening is first we are saying, and then this is get, right? It will return a type confirming. Get is always going to get or return something has to be returned here. Now whatever will be returned, that will conform to view. Reason being, this is a self dot body. This has a type colon self dot body, and then this body is basically, so by associated type we are hiding what exactly is getting returned, and this view indicates that whatever we are going to return is a view, is a protocol that will conform to this view. So let's okay, let's do some, let's see. So let me use a pen and paper. So here we go. Let's get this thing out. Let's get rid of this. Perfect. Now, let's come back here. So I say, what happened to my pen? It should work now. Just give me 1 minute. Just give me a minute. We'll get that. First, let's see the advantage of associated type, right? Like what's the okay, let's see. Now so this is my protocol. Protocol iterator. Let's change color, make it fancy. This is iterator. This is parentheses. And this is okay. Now I have a struct conforming to this. So I have a struct int iterator. Then I do now I'm going to conform, right? So let's keep this in blue. So I say iterator parentheses. Okay. Now we will have to talk about the type, right? Because now Swift is a type safe language. So this will, if you don't mention type, we get an error. So here we will get an error. Now, so now what this associated type does is it helps in creating a generic creating. That means the struct conforming to this protocol will give me the type. Perfect. Now oh, did we? Okay, let's go ahead. Now let's come to our view. Scroll. Where is this? Oh, now this is the V protocol, right? So I say protocol, then I write view, then I parentheses, then I say what will the first I'll write associate, and then this is, let's change color. Surrender this small, right? Yeah. So see that type body. And this is this is a property, right? Body colon. This is okay. Now let's see. Yeah, type is not. Oh, this doesn't have a type. Oh, this is wrong. This should be. So yeah, there is. Now some people may say that this is a type. No, this is not time. This indicates that it will conform to you. No type mentioned. This is property. Now this is a getter. So this is going to return a body. Okay. Now whatever. Now this is going to return, and self.body indicates that's whatever it indicates, it will conform to you. It's a return type, right? Now the way Swift is layout, so then I have struct content view colon view. So now this is the view protocol coming in, and then I have to mention two things, right? This, oh, let's change. Okay, this, let's have the arrow as yeah. Listen, we need this type, and then this body. So here we need to mention the type, and then we need to mention the body thing. We need to implement this, what that is. So now we are coming with body now. So this will return, it will return something that needs to conform to view, right? So then we are not especially and then okay, this, the sum indicates this, its type, and then we are saying view, and we are saying that it's conforming to the web protocol, whatever is getting returned. So here we are creating an instance. When we, if I remove this, the preview will go out. See, I mean there's nothing here, so let's do some, let's have text, and then let's, no, okay, let's double click, and then hi, let's get them done. See, hi has come. So that is what we mean by this. So this is like in creating an instance. Now this sum means that the associated type is a type of, like it basically indicates it is some view. So, and that view indicates that it's conforming to the web protocol. Sum provides the type to the associated type body. View indicates the conformance. Yeah, that's exactly what we are doing. So this part is of the view protocol. Now this is a type annotation, that the return type of a property is an opaque type that conforms to view. So return type conforming to, how do we write it? Is it colon? Yeah, it's, we make sure, okay, return type okay, if in Swift we can specify that the return type of function or method conforms to a protocol by declaring the return type as that protocol. There's a basic example. So to get animal, so this protocol function, okay, animal equate Swift. No, wait. So the return type of get animal conforms to equatable animal. Oh, okay. So this is dog, right? And then I'm saying this is the struct. The dog get animal returns, and where is get? Oh, so let's come here. Oh, now this arrow basically indicates that in case of a single return, there is no need to mention that arrow. Some, okay. So some, instead of mentioning what exact, we are saying that it's whatever this is going to return, this will confirm to you. This is a getter, right? And this is a get closure. This is a, let's see, this is get closure, no return, mention explicitly as single return. So when there is single return, there is no like there is no, specifically you don't need to mention that return this. Oh, this is nice. So then some view, so we are saying that it is going to return whatever it returns will conform to the view. The exact type is hidden, but we know that it will conform to the view protocol. So that's, so this is a this is an anonymous, right? So when in an anonymous okay, let's see. So when we have an anonymous function with no parameters, anonymous function with no parameter and single return. So then there is, the parentheses can be opted out, I guess. Oh, so there's no need to mention the parentheses. Is it, or shorthand is, can we omit the parentheses? Single return, right? Yes, you can. Oh, see, this is again implicit. See, this is the best thing. What is, so what this is, see, no return time and implicit return, making hello Swift. And what if I need to, no parameters but single return? So that's what, how is breaking down. See, so you can write over here, or oh, can we mention the type And when we are mentioning the type, right? So for example, this is string. I say using get. So I say get. So I'm the shorthand. It's like a shorthand thing. So using glad closures, I don't only I need, but then associated, right? So then see what is going to happen here. So he's saying this is string get, right? So then while implementing, this is single return, no parenthesis, and this is the same type. This is indicating that the type is string. Oh, this is a good example. Let's break that down. So let's see this. Where is my pen? Here we go. So this is protocol greater. You have, oh, this is small. So I say where greeting let's change this thing. Let's start from here. Say where greeting colon string. So get indicates there is a return I'm going to get, right? And this is return type. So now let's confirm. So I have a struct. So I say Spanish greater, and then say conforming to this greater. Then I need to have this thing over here. So I'll say when greeting call. Now this is a string, and so we can omit here as well, right? Just write hello. This indicates it's a single return from get. Same thing is going to happen here. So this is some view type, this is single return, this is body property of the view protocol. Here we are creating an instance of the struct content view. This is how it's working. Okay, let's see. That was, as you see, this is the return. Okay. In this case, I've already contains text. Now the thing is, now see, even this text is like a structure, right? Because we are passing in some int, but then we are not mentioning. Is it like a case? So let's see the text structure. Let's see how does that look. Okay, this is the struct. Now what this dot and this is, we'll see that as well, but then let's only see. So this is struct. I need a this is an init, right? So I need to pass a string. This is when we remove underscore, we do not need to mention content over here. Like this is content, basically hello world, so we do not to mention that. Okay, so like if you see the definition here, see attributed content, this is actually how it's inbuilt. So you can select this, come here, this will be a string, right? This is the actual one. Control set, come here. This is it's an attributed string, so a string has to go in here. So I said subtract, sorry, text, or just no, we haven't studied about what modifiers are. We'll see that later on. So text, so this is basically creates a text view that displays style attribute content. Okay, so we will continue from here in the next video. Thanks. Bye bye.